In the last module, we have learned about the static scope rule in Java and also a little bit about writing recursive program. In this demonstration, we have a quick illustration about the different concepts regarding the scope rules that we have learned and then recursive program writing. Before going to that, we should have basic control structure. I know that if you are already an experienced C programmer, for you all those basic control structure is known to you, but those are new, for them it will be just okay. To make the consistency, we will just discuss about quickly. So, there are different loop structures and then switch case will be covered, and then finally, we will discuss about the scope rule and then Java program writing using recursive function. So, let us have the quick demo about. First, our example is how we can use the while loop. Let us see the program. So, this is the one program. As you can see, this program is basically use the while, and within this while and there is a condition. That means, this loop will continue until the value of count is less than 11, and you can guess that what this while loop will do. It basically includes one print statement. It will basically print the odd numbers starting from 0, okay, next odd number start after 0 is 1, of course. So, 1, 3, 5, 7 like this one. Now, let us run this program, so that you can see how this while loop will roll it. You write the compilation, you have to compile it, write the Java C. So, okay, so this is the program that is compiled. Here we can see that program is compiled successfully. Now, let us run this program. So, Java, yes, and as you can see, this is a printing first 10 odd numbers, it is there. Now, so this is the one form of while loop. Now, let us have another form. We can open the 5.2 program. Yeah, so this is another program, and it is basically same thing. In the earlier program, it is printing the odd number, but as you can see, this program is to print the first 10 even numbers, and here instead of while we have used the do while statement, and it is the same thing, but obviously there is a difference between the while and do while. Now, let us run this program, and then okay, let us first we have to compile it. Yeah, so running this program, yeah, so it basically print it. Now, okay, if I ask you what is the difference between while and do while. So, while basically check the condition first, whereas in the do while at least one loop will roll, and then once the one loop is done, then the condition is checked at the end. So, the difference is that while loop may not execute in single loop, but at least do while at least one loop will be executed. Now, similar to while and do while, there is another construct in Java, it is called the for loop. For loop is totally different than the while loop or do while loop. Now, in case of any loop, there are three things are to be considered. Initialization from the loop variable. In the first two examples, the loop variable was count. Now, initialization of the loop variable, and then the condition checking, that means whether the loop has reaches its the termination condition or not, and then updation of the loop variable. Now, all the three things can be done using for statement in one line. Now, here we can see the for statement. Here int I, in this case it is the loop variable, that means it is the this is the variable I which controls the execution of the loop. So, here int I equals to 1, that means initialization of the loop variable as 1, and this is the condition checking, that loop will continue until the value of I is less than 11, till the value of I is less than 11. Once the value of I is equals to 11 or more, it will exit the loop, and I plus plus, once the loop is completed on its term, then it will increase the value I automatically using this one. Now, here in this for loop, as you can see, is a simple print statement which basically print the value of I. This means that this for loop will print I equals to 1 to I equals to 10, the 10 first integer number. So, if we run this program, then we will be able to see exactly how this for loop works for you. Yeah. So, this for loop, as you expected, that okay, it prints 1 to 10 consecutively. Now, so this is the example of the do while and for loop are the three loop structures in Java program. It is very similar to the structures that is there already in C and C++. Now, the loop can be controlled or it can be terminated abnormally, and for this thing there are two more statement is there called the break and the continue. So, the purpose of the continue statement is that if some condition is satisfied, it will not execute the remaining part in the for loop for block. For example, in this example here the for loop we have this, if I, that means if I mod 2, that means if I is an even number, then it will not execute the next statement, namely system.out.println, and it will go to the next round of the loop. So, continue is basically skip the remaining part in the for loop, it is going to the loop again. Now, if we run this program as it is, okay, you can anticipate that this will print the first statement in the for loop is print, that means it will print two numbers in one line, and whenever there is a mod it will go to the next line like this one. So, is a the print, it will print the values, yeah, here we can see 0 1 in one line and then mod. So, 2 it goes to the next and so on so on. So, continue statement is executed after every even number in the for loop. So, this is the idea about the continue. Like continue, there is one break statement. The break statement, whenever a condition reaches, so it is basically terminate the loop without any satisfaction of the loop control termination criteria. So, this is an example. Here we can see here I mod 10 indicates that whenever the value of I reaches to 10 or multiple of 10, whatever it is there, so the loop will be terminated. So, in this for loop, as you can see, int I equals to 1, and you can see the condition here is basically null. We do not give any condition. That means, if we do not put any condition checking there, then that loop will supposed to execute for infinite times. But if there is a break statement and if there is a condition which satisfy the condition, then the break statement is execute, then loop will be terminated there. So, although it is look like an infinite loop, but because of the break there is a condition that it will terminate the loop. Now, let us run this program. As you can see, it will print I equals to 1, 2, 3 until I equals to okay, till it reaches I equals to 10. Once I equals to 10, loop will break and it will terminate the loop. Yeah. So, it is basically the concept that okay, how the break statement is there. Now, so we have learned about basic control structures there, mainly the while, do while and for loop with break and continue. Now, in addition to these simple control structures, there is basically a decision structure if else. If else are very simple, we do not have to discuss it in a detailed manner, but like this if else, the multiple decision checking is done in Java by means of switch case. Now, we will discuss about our next program in switch case. Now, here is a one example. Okay, before going to this, to discuss the switch case statement is basically how we can test whether a number is prime or not. So, it is basically usage of both for loop as well as if statement. Now, for basically we have to test till certain number is prime or not. The condition is that I less than num2, because we have to check for these kind of things. That means, if any number within this num2, if we have to test that whether num is a prime or not. So, up to half of these things we have to roll this loop, so that we can check that any number within this range it is divisible by this number or not. So, the divisibility check by num mod I. So, it is basically check the divisibility, that means it is divisible by this I, where I is basically 2 to that range, and then if it is there, then it will check that okay, if it is divisible, then it is not a prime. So, each prime is a Boolean variable, declares a false, and then is break, because no more testing is required, otherwise it will continue. Now, we can test this program by passing an input from the keyboard, and here is the execution of this program, capital. Yeah, so 5.6, 5.6. Okay. So, now we 6, as it is known as 6 is prime. Now, let us run this 31, 31 is a prime. So, it will check that prime. So, like this. So, you can test that using this control, we can test this. So, logic is basically any logic can be implemented using for or while and then if else statement. There are another logic structures is there, as I told you the switch case structure. Let us consider one simple program, and this switch case is basically here we can see. So, and we can see first few blocks is their do while block. It basically print something until you type 1 to 5 any number. If you type anything, so this loop will continue. Okay. So, in order to come out from this loop, you have to either print 1 or any number less than greater than less than 5 actually here. So, if any number you type greater than 5, it will basically break the loop. Now, let us see, once the value of I is chosen from here, that means user can enter any value which is greater than or equals to 1 to less than or equals to 5. Now, once the value is read, and then there is a case. So, depending on the type, the number that you have chosen, we have lot of switch cases is there. That means, if I that we have written in the first statement, here the choice basically. So, depending on the choice, it will depending on the different statement will be executed. If choice is equals to 1, so the case 1 code will be executed, and if choice equals to 2, the case 2 code will be executed. Similarly, for all 5 cases, the different statements are there in this program, and you can see for. So, here basically switch based on the value of some switch variable, here choice, the different cases will be executed. All cases are basically few codes are there, and then all case statement will be at the end of this case statement there will be break. That means, after this case is there, it will break that switch loop actually. So, this is the structure of the switch case concept in Java program. Now, let us run this program, so that you can understand how it will work. So, advice is that you should have this code and then try to practice of your own, so that you can understand how the codes are working. Yeah. So, here now choice 1, if I press say 9, then you can understand what will happen, it will loop. So, it is asking this one. Now, again choice say 2. So, it is basically tell about the switch. So, this is the way that program can be executed. So, this is a simple example of switch case statement. Now, so these are the control structures which are widely used in your Java program, and you have to learn it, you have to practice it, so that you should have very skill about all these programs. Now, okay, once that things are there, our next topics in this demonstration is the usage of scope rule. As we have discussed about that, Java follows 2 scope rule, static and dynamic. So, in this demonstration we will limit our discussion to static scope rule only. Now, let us have a quick look to this program, and here we can define a class. The name of the class is demonstration underscore 58. This is the name of the class, and under this class only main method, very simple class. And you can see the for the main method, the matching and then beginning curly brackets are there. In addition to this, we define a block. A block in a program can be specified by means of patching parenthesis. So, here the block it is there. Now, in this block, inside this block, you see x equals to 10 as an integer variable is declared. Now, so far the scope rule is concerned, the value of x is valid within this block only. That means, it is valid that system.out.println x is correct. However, outside this block, if we try to access say system.out.println x, then it will give an error, and that error can be reported during the compilation time. Now, let us change this, the last statement system.out.println x, that means, we are trying to print it although it does not have the scope. Now, save the program and run this program, and let us see what will happen. So, it will give an error because system.out.println x, the last statement in this class, has out of scope, the x does not. So, it is basically compilation error. Now, again if we make it commenting the program here, and then we will see this program will be compiled successfully and also executable. Save this program. Okay. So, program is now compiled successfully, earlier it was giving error. Now, the program will give the result that it is x equals to 10. So, you can understand the scope is a very simple example, but it is understandable that what is the scope of a variable inside a block. So, this is the scope in a block. Now, there are few more example. This is another example you can see, and how you can understand also what is the scope of this example. Now, can you tell me what is the scope of this example? Here x is the variable for which we want to discuss the scope. Now, here if you see here int x equals to 0, it is declared within the for loop. This means that this is the scope of x within the for loop only. So, within the for loop there is a print statement which print the value of x, it is okay. But outside this for loop, if you attempt to print it, it will give an error. So, let us uncomment this one and then run this program, then you will be able to understand that it will give a compile time error, because here the statement it is out of scope. So, here the x, the scope of these values variable x is within the for loop. So, it is an error, is defining that the scope is not there. Now, again comment it, run the save the program and then run this program. Yeah, no compilation error, and run it, it will print, basically for loop will be executed successfully in this case. So, for loop is executed, you can see it. Now, how we can change the scope rule? Now, let us come to the another example, so that we can see how the scope can be increased here. So, the next example similar to the last example. Here you can see int x which declared outside the for loop. This means that the value of x is spread throughout the for loop as well as outside this for loop also. Earlier when it was declared within the for, it was only scope within the for, but in this case the scope is the entire program. So, this program is self explanatory, as we have already understood about it. So, this is about the simple concept of scope, and okay, fine. So, let us discuss about one more example which has the different context of the scope. Let us run the program 5.11. Yeah, okay, fine. So, this is the one program. Now, let us quickly examine this program, watch this program little bit. Here x and y are the two variables declared, and the two variables have the different scope. So far the scope of x is concerned, as it is declared in the main method, this means that the scope of this variable x is the entire method. So, anywhere from this method the value can be accessible. On the other hand, if we see the y, int y 20, which is declared within the block with under this block under f, that means the scope of this y is within this block. So, in the statement after system.out println x and y, the next statement is valid, because it will be within this scope. However, outside this y equals to 100, it will give an error. Now, let us run this program, and then we can see that it is giving the compile time error. So, all these error will be reported during the compile time, that means Java compiler will check the scope of all variables for you. So, if there is any error in the scope, then it will report it, the compilation will not be successful. So, this is the compile time error we can say. Now, if we comment it, then definitely because scope is now closed, and then it is it will work perfectly. So, here no compilation error, program will give the output according to the program. Okay. So, we can understand about the concept of scope here. Now, there are many more things about the scope. We have discussed about that global variable idea in Java program. Java does not support the declaration of global variable. However, the concept of global variable is by means of the concept of class variable. A class variable and an instance variable, as we have already learned about it. Here for example, x, y, r, these are the instance variable, because they are declared simple as a type. On the other hand, if we declare a variable with a keyword static, then it is called the class variable. In this case, we can see the circle count is an example of a class variable. So, we have declared here one class variable, namely circle count, and then 3 instance variable x, y, r. And these are the usual code of the constructor of the class circle. So, we have already discussed it, I do not want to discuss it more. And the two methods, circumference area as usual. Now, let us come to the main method here. Now, you have to just watch the main method little bit carefully. So, in the first statement we create an object of class circle, the name of the object is C1, and it will print the C1 dot circle count. Now, here once the object C1 is created, it will call its constructor. Now, here the default constructor. So, if you go to the default constructor, then you see in the default constructor here in the last constructor that we can see. So, it will basically it will initialize all the instance variable as 0, 0.1, 0, 0.0, 0.0 and 0.1 x, y and r, and the circle count will be increased by 1. Initially when we define this, circle count is 0. So, global variable is 0 initialized, and after this whenever the constructor is called for this, it will increment this one. So, now let us come to the main method here again. Yeah. So, once the circle C1 is created, so C1 has the value circle count. This means that if we print this, it will print the value 1. On the other hand, next C2 create object is created. Now, it will call another constructor 5.0, which is the second constructor in the line of different constructors are here. So, public circle double r, here also circle count plus plus, that means it will increase the circle count by 1. So, after the C2 object is created in the main, so the circle count become 2. So, it will print the 2, and similarly circle C, this is the third constructor, first constructor I should say, it will be invoked to create the circle class object C3, and then C3 and then circle count in this case will be again increased by 1, and then here the okay fine right circle C, this is the second constructor, right, this one. Okay, now, it will print the 2. Now, let us run this program, and then you will be able to see the output. So, here each circle object is created. Once the circle object is created, the static variable will be processed according to the object's construction, and then it will basically run the it will print the current value of this one. And here we can understand that the circle count is a global variable look like. For all instances of the objects, there is only one instances of this variable. So, here we can see the running of the output is basically 1, 2, 3. Now, let us switch to the program again, and you can see okay, we are just giving to the last statement which has been commented here. I just removing the comment here. Let us uncomment this statement. Yeah, okay, uncomment this statement. Okay, fine. Now, comment it. Now, little bit bigger the window here. Okay, fine. Yes. Now, if we see the right. So, after creating this C1 right one, and we are now in this statement. Now, can you tell me what exactly the value that it will print? So, here in the first object circle count has been created 1, 2, 3, and then when we have come to here. So, the circle count for this C1 is 3 and again 3 and 3. So, basically the latest values of the circle count will be accessed. So, it basically indicates that let us save compile this program and run it. So, here in the last statement we will print the value of circle count, which is the ultimate value after the end of this program. So, here you can see it printing the 333, this is the latest value after that. So, it has basically one instance, and then one it is updated by any object, it will be reflected to any other object which basically has the access of this value. Now, so this is the idea about the static variable concept. Likewise, there is a concept of class method and instance method. Our next program will to illustrate the concept of these two methods in a Java program, the class method and instance method. We have already discussed about that a method is an instance method. In order to execute this method, an object is required. So, via an object the method will be called. On the other hand, the class method is a method which does not require any object to be created, the method can be called itself. So, this example basically to illustrate the concept of class method and instance method. Now, let us hear all the circles are basically instance method, because whenever you have to create an object, all these constructor will be called automatically. Say they are by virtue of default, they are the instance method. Now, we declare one method, let us go to here, the circle bigger, public circle bigger, the second, yes. Now, this method little bit bigger the window, yes, yeah. So, okay, fine. Now, the first method we can see bigger. So, this is the method public circle bigger circle C. So, method it basically argument will be an object circle, is the C dot R greater than R, return C, that means that C is a bigger circle, else return this means the current circle. So, this is the one simple method, and this is called the instance method. On the other hand, the another method bigger is an overriding method we have discussed, but this method is different to the previous method by two things. One is called the static keyword, the second one has the static. This indicates that this method bigger is basically the class method, and also it is different from the argument point of view. Earlier only one argument, whereas this is the two arguments, all arguments are of type circle type objects. The code is like this: if A dot R greater than B dot R, return A, that means A is a bigger circle, else return B. So, it will basically return, that is a return type is circle here in this case. Now, let us see the main method here. We create an object, four objects here of course. Anyway, so first two objects are the type class circle A B, and then here we can see the A dot bigger. So, basically because bigger method is invoked with reference to the object A. So, it is an instance method. On the other hand, the second call, so bigger method is called with reference to any object, it is basically in terms of circle dot bigger. So, that means without creating any object this method is called. So, this is an example of invoking the class method. So, here the two invocation, the instance method and class method, and it indicates that the way of the class method works differently than the instance method like this. So, this is an example of instance method and class method. Okay, so, these are the main concepts, those are there in Java so far the static scope rule is concerned. Now, let us switch to our demonstration to give the execution of recursive program. We have already discussed while we are discussing about the theoretical is that recursive program writing in Java. So, let us first run the recursive calculation, recursive way calculating the factorial. So, this program is well understood I believe. So, here factorial is a method which is defined in the class recursive factorial, and then recursion is basically following the recursive definition of factorial calculation. The code is like this, very simple, n factorial is equals to n star factorial n minus 1 with termination condition that 0 factorial equals to 1. So, this is the implementation of this factorial definition of n. Now, in the main method we create an object of type of the class recursive factorial here, and then pass the value to this object from the keyboard as an input, and then we call this x dot factorial x dot n, that means we call the method in this object of the class recursive factorial and run it. Now, let us run this program quickly, you can understand that how it will run. recursive. Okay, fine. Now, as it is a input to be passed, because arcs 0 is there, so we should give the input say 5, right. If we run this program again with some say larger value say 10, it will also execute for you. Yeah, so it is like this, but it cannot take very large number. Say for example, if we give say 100, you will see whether your program is not. So, factorial of 100 is 0, it is giving, it is because it is out of bound of this one. So, in that case integer has its own limit. So, if we declare say long integer instead of int, it may take some larger values anyway. So, changing this we can change this one, but we have to do a lot of changes for that. Okay, it is left as an exercise for you. Now, let us come to the another recursive program to print the Fibonacci sequence. So, this is the program we have already familiar to the program that we have discussed in our last module. And so, here again the recursive definition of a nth factorial is basically n minus 1 factorial plus n minus 2 factorial, and then termination condition is that 0th factorial equals to 0 and then 1th factorial is 1. So, these are the two termination condition followed by the recursive definition. It is the same as writing the factorial. We create an object of type recursive Fibonacci. Here is the class where we have defined the recursive method Fibonacci, and we call this, and this for loop is basically print in succession all the Fibonacci number till the x dot n. This is the user defined number that up to which the Fibonacci number you want to print. Now, suppose you want to print up to 10th Fibonacci number. So, we can run this program with passing input. Here input needs to be passed through the keyboard, let it be 10, and we can understand that how it will print 10 Fibonacci numbers in the Fibonacci series. 10. Okay, so, it print that first 10 Fibonacci numbers in the Fibonacci series. So, this is basically the recursive. Now, let us come to the GCD calculation that we have discussed in our theoretical class. So, GCD calculation is basically has this kind of recursion rule is like this one, and we have implemented. There is a few more termination condition. Now, you can see in case of recursive factorial only one termination, in case of Fibonacci there are two termination condition, whereas in case of GCD a couple of termination condition is there, and all termination condition followed by the recursive call. So, in this case recursive call GCD m n mod m. So, this is as per the recursive definition of this one. Now, here two integer values are to be passed, and then Java program will call for this recursive function which is defined here as a GCD, and we call the GCD with the two value passed to it, and it will call. So, G is a object of type this class is created and call this function, and then it will execute it. Let us run this program so that we can understand about its execution. Okay, first let us enter 31 and then 13. So, this is two input you have to give it, give two input 31 and 13. Okay. Now, you can see that GCD is 1. Now, let us run this program with say 33 and 11. You can understand the GCD that value it will give you, right. Even if you give 11 and 33 also it will work. Yeah. Now, if you give say 0 and say 100, you can understand that what is the GCD of this number 100. So, it will print the 100. Okay. Now, if you give, so this is the way that GCD, and this function is called for integer value only, you should pass always integer. If you give some non integer value, it will report an error. For example, if we run this program passing say non integer value, it is not acceptable to the runtime inverter, Java runtime inverter, say giving an error. Yeah. So, it is basically you have to give the integer value always. Now, so we have learned about factorial calculation. So, factorial calculation, Fibonacci series calculation, GCD calculation like this one. So, more important thing that you should understand that how you can cast a program by following the recursive definition. If every program has its loop, all this program has its counter example of recursion actually. So, if a program needs to be solved by means of some looping construct, then the same program can be solved by means of loop recursive version also. Now, let us have a quick look of this simple example. You can understand this is the program we have declared recursively. So, it basically here is the my method is a recursive method which is declared in the class demonstration under 5.1 scene, and the method has the termination. And one important thing is that every recursive function should have termination statement. Without termination, the recursion will go on infinite execution, never terminate. This is not desirable. So, every recursive program should have. In this case, we can see that counter equals to 0. So long counter is not equals to 0, it will go on counting, and in this case my method whenever it will call first times, it will print the value of count, and then my method call will be called again with reduced value of count. So, if we passed say counter value, it will call subsequently less counter, so on, and then print all the time counter, and when the recursion is over, it will come to the previous counter value. So, now if you see whenever before recursive call, it will print, and then on recursion it will print some values and go on printing, and then let us see exactly what is the output of this call. So, if we call this recursion with 10 as a value as counter, how it will do it? I can explain that why this output is there. You can also explain that how this output is happened to this program. Yeah, you can see here the two series of statement because of the two print statement, and then recursion is going on printing this one, and then recursive call, and when the recursion is back from the loop on, it is again starting this one. So, there are two series of statement and the recursion is there. Actually, recursion execution use a stack. It basically before terminating recursion, it goes to the call of the recursion, so on. So, that is why it is there. Okay, so, this is the one example. Now, let us have the quick look of the another example for your own practice. So, again you can learn it from this. It is in the same line of the previous example one. You can guess that what input it should give it. Again P is the method which is defined here recursively. Now, let us run this program. On it. Okay. After the execution of this program with the value of P as 5, here we do not have to value 5, it will print this one. Anyway, so regarding the scope, the control structures, and then recursive program writing is a matter of practice. So, I advise you to practice more and more programs in this line, so that you can learn it. For your own practice, if you need the program, all those codes that we have given here demonstration, you can have it. You just send us a request, so that we can send it to you. Thank you very much, and have fun for the Java programming more. Thank you.